of the curve. So we got square root of 26 minus x squared minus 4y squared at the point 1, 2, and use it to approximate the function, this function at this point. So basically we want to represent this curve by a line near or at the point 1, 2. So the line will be, for this curve, the line that's denoted by L as a function of x and y, that will be, just evaluate the function at the given point. Here is x naught, y naught, we can say that. So f at x naught, y naught. And now we need to find the slope, pretty much the derivative. So find the partial derivative of this function with respect to x and evaluate at the point, and plus find the partial with respect to y of the function and evaluate at the point. Okay, that's the linear approximation of this curve. So let's evaluate this function at x naught, y naught. I'm just finding ingredients, individual, there are 3 different parts. So the function at x naught, y naught means 1, 2. 1, 2 is square root of 26 minus 1 squared minus 4 times 2 squared. 4 times 4, 16. So 17. 26 minus 17 is 9. Square root of 9 is 3. Okay. Next we need to find partial derivative of this function with respect to x. Fx at xy is, this is basically this one raised to 1/2. So from the power rule, 1/2, that function, 1/2 minus 1, negative 1/2. 26 minus x squared minus 4y squared times derivative of this with respect to x. So 26 derivative 0, so negative 2x minus 4y squared, that's 0 as well. So let me simplify. These 2 from top and bottom can be cancelled. So negative x over, because it's something raised to negative 1/2, when I put on the bottom, so square root of 1/2 means square root 26 minus x squared minus 4y squared. Now here we need to evaluate this partial derivative at 1, 2. Let's do that. So fx at 1, 2, so minus x is 1 over square root of, this is square root of 9, which is 3, right? We already did that. So here, square root of 26 minus 1 squared minus 4 times 2 squared. So it will be square root of 9, which is 3. So this is 3. Now next we need to find partial derivative with respect to y of this function. Again, this is this raised to 1/2, so 1/2 26 minus x squared minus 4y squared raised to negative 1/2 times derivative of inside from the chain rule in terms of y. So 0, 0, negative 8y. So we can simplify further. 2 goes 4 times. So negative 4y on the top over square root of, because negative means put on the bottom, becomes positive 1/2. Power 1/2 means square root. So this is 26 minus x squared minus 4y squared. Let's evaluate this partial with respect to y at the given point 1, 2. So negative 4 times 2, 8, xy 8, over this one is 3 when we plug in 1 and 2. Okay. Now we have everything. f1, 2, that's the fx naught, y naught, fx at 1, 2, fy at 1, 2. Okay. Then this curve okay, is approximated. I can write fxy can be approximated by a line, straight line, which is given by this formula. That is this value f at x naught y naught, that's 3, plus the partial, okay, I forgot something here, these are all the numbers, this one times, this one is value times x minus x naught plus this value y minus y naught. Okay, so 3 plus this value is negative 1/3, so negative 1/3 x minus x naught, which is 1, plus fy x naught y naught, that's the value here, negative 8/3 y minus y naught, that's 2. Okay, that's the linear approximation of this curve, I mean this line. So basically this curve is now being represented by this line at the point or near 1, 2. Okay, and this is being a line, straight line, easier to manipulate than this curve. Then now we need to use this to approximate the function at this point. So just plug in x equals 1.08, y equals 2.05. So evaluate the function at 1.08, 2.05, that is approximately equal to this line, just plug in here, 3 minus 1/3 times 1.08 minus 1, 0.08, minus 8/3 times 2.05 minus 2, so 0.05. Now we can use our calculator, 3 minus 1/3, 0.08 minus 8/3, and it comes out to be 2.84, about this one. Okay, so the linear approximation for the curve at the point 1, 2 is this, and the approximation for this f is 2.84. Final.